Alright guys, so we're doing parametric equations today where you're going to get function of function of t that is going to represent your x coordinate and a function of t that's going to represent your y coordinate. Think of t as time. So it tells you basically how the function is moving according to the time. So just a quick example, if you have x of t to be t and y of t to be t squared, and we are just worried about the interval 0 to 2 as far as time goes. Basically what's happening here is, you could think about it this way, is at time equals 0, your x and y coordinate would be 0, 0 just by plugging in t to be 0. For example, if it's 1, you would have a point 1, 1, and if it's 2, you would have a point 2, 4, just by plugging in 1, 2, etc. Now on a graph, what is actually going on here is, if you're looking at time equals 0, you have the point 0, 0. If you have the time equal to 1, you have a point 1, 1. And if you have a time equal to 2, you have the point 2, 4. Now, this also tells you the direction. So if we're going time equals 0, 1, 2, that means that's the direction of your graph. So you're going in this direction. Now, a couple things here that you could always solve for is to actually see what the function looks like. Basically what it means is x is equal to t, y is equal to t squared. Knowing that, we could do substitution where if I plug in x to be t, I could get y to be x squared. We all know what that looks like. That looks like this. But because of our restriction here, that does not necessarily mean that's what our function is looking like. We are just using our values from 0 to 2. So actually our function is just this portion of x squared, and we show by the direction that it's going in those arrows. Another way to think about it is, at each time it shoots a point onto the curve and plots it. So that's actually what's going on there. Okay, hopefully this is not too ridiculous and I don't sound like an idiot, and this makes some sense of parametric equations. Next video will be on derivatives